Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I will be guiding you through this problem today. So let's just jump at it. Alright, how much energy is lost when 125 grams of steam at 100.0 degrees condenses and cools to 50 degrees Celsius? Alright, let's take our highlighter. Let's highlight some important things. 125 grams of water, that's probably pretty, not water, steam at 100 cools to 50. All right, that's our important pieces of information. Let's write down what we need to know here. Mass equals 125 grams. We got temperatures, we got T1. 100.0, T2 equals 50.0. All right, so there's some important information, but now we got to be really careful here, guys. We have a steam that's condensing. Oh, wait. We have steam at 100 degrees Celsius is going to become water, or liquid water, gas water, liquid water, at 100 degrees Celsius, and then that water is going to cool to water at 50 degrees Celsius. Oh, wait now. This is a two-step question. We first have to know the heat or the energy here and here. There's energy in two steps, and the energy is different for both. Well, this is a heat of vaporization question. This is a specific heat question. So we have to do two calculations. First, to go from steam to hot water, let's say. That's heat of vaporization. And we know that the heat of vaporization is 540 calories per gram. We know that. How do we know that? We look it up in a book. Well, I'll give it to you on an exam. You don't have to memorize that. Okay? So we know that for every gram of steam, it requires 540 calories to be removed in order to condense 1 gram of water. We have 125 grams of water. So we're going to multiply that by 125 grams. And that's just the energy to take the steam and make it water. Make gas water to liquid water. The temperature doesn't change. Notice, 100 degrees to 100 degrees. The temperature never changed. Just the state of matter changed. You went from a gas to a liquid. All right, let's crunch some numbers real quick. What do we got here? 540 calories multiplied by 125 grams is going to be, look at that, 67500 calories. A lot of energy just to condense steam. Just to condense it. It's still 100 degrees. It's not done burning your arm yet, if you want to think of it that way. If you hold your arm over a boiling pot of water, the steam is going to pump a lot of energy into your arm just to condense and make your arm wet. And then it's got to cool down some more. So remember, we're still at 100 degrees Celsius at this point. That energy has left the steam, but the steam is still at 100 degrees. So we have to do now hot water to, let's just say, less hot water. Hot water to less hot water. It's still 50 degrees is still pretty darn hot, fellas. All right. So now, specific heat, or the heat equation. Heat equals specific heat, I'll just abbreviate that SH, multiplied by mass multiplied by temperature, or the change in temperature. So specific heat of water is 1.00 calories per gram degrees Celsius. That's going to be multiplied by the mass, 125 grams, which will now be multiplied by the change in temperature. Specific heat deals with the change of temperature. Heat of vaporization is only at 100 degrees. So water goes from steam at 100 to liquid water at 100. Now we're dealing with the temperature change right here, 50.0 degrees. That's 100 minus 50. Okay, so that's the expression, that's the setup. So now, get that calculator nice and organized here. There we go, that's pretty good. 1 multiplied by 125 multiplied by 50. 6,250. That's how many calories it takes to cool the water to 50 degrees. So the overall energy that is lost in this process is the addition of this with this. But now let's round this to 3 significant figures. Boom, done already. Isn't that nice? It's already in 3 significant figures. So now the final answer is this and this added together, because it's a whole process. This is the first step, this is the second step. So let's just jot that down up here. 67500 calories for that step. 6250 calories for that step. And now we're going to add them together. Total energy lost. Total energy lost will be 67500 calories plus 6250 calories for a grand total of, it's going to be a rather large number, I think, plus, 67500 plus, not multiply by, plus 6250 equals, ooh, look at that, 73750 calories. And let's put a little square around the final answer. That is the total energy lost. This is the energy from each step. Add them together for the total energy lost. All right, now that is a hard question. That's got a lot of parts and pieces flying around. It's probably confusing the first couple of times you do it. Do it again. Get it straight in your head so that on an exam, the questions, which will probably be easier than this, you'll be flying through them like they weren't even there. Don't do questions like this, and the questions on the exam will become unsurmountable because you haven't practiced enough. All right, now with that, I'd like to wish you good luck and good chemistry.